Then we have a number of improvements to performance in the area of data modification. The big one here is that update and delete handling has been significantly reworked. And the main benefit of that is that planning is now much faster in the case where an update or delete is performed against a partitioned table, particularly if there are a large number of partitions. However, there's also some impact of this change on update in general. What I expect is that it's going to be a little bit faster when you update a table that has a large number of columns, and perhaps slightly slower for a table that only involves a very small number of columns.
I think this is a very interesting feature. We've been improving performance for partition tables since they arrived in Postgres 10, and this is still a good step in the same direction. I constantly keep seeing customers having wide tables without being partitioned and experiencing performance issue, and I keep pushing them to partition their data, and they always fear that it could make their performance worse. I always tell that when it comes to performance, the only way to be sure is to do a benchmark. But I think that we have now a very mature system of partitioning with Postgres. And we have something that is very usable in production and that is very great for performance.
Yeah, I think you're right. And benchmarking is essential when you're deploying any application to see how it's actually going to perform in production. I noticed Robert here, though, says planning is much faster. I mean, updates and deletes can be pretty heavyweight operations anyway. Do we think the planning is actually going to make or faster planning is going to make a noticeable difference for most users?
I've seen some users who had too many indexes, and when I say too many, it's they were storing more. Their indexes size was higher than their data size, and it was not a data warehouse. And they had a problem because their statistic depth was not enough. So the planner was most of the time wrong and picked the wrong plan, and it had a lot to choose from. And we made things better by increasing the statistic depth, but this increased the planner time. So anything that can make planning time better means we might get better statistics to get a better plan when we have a lot of plans to choose from. So I think that could be good.
I think any performance improvement is a good one.
Yeah, I mean, we've you're right, Lætitia. Since Postgres 10, we've been sort of trimming around what this thing can do. I think it was in one of the earlier releases, maybe it was 12 or 13, where we started. In our original version, the planner would open every partition, whether it was going to be valid or not, right? And then it would prune it later in the planning process. And obviously, if you had like hundreds of partitions, just physically opening all those, even though you're going to discard them all, was something that was slow. And what this is, I believe, looking at the release notes, what effectively I think it's doing is taking that thing that we did in 12 or 13 for select, and then moving that to update and delete, because effectively an update delete is like a select with a update on it, or a select with a delete on it. That's why it's listed as update/delete in the release notes, because you're using the same infrastructure, but you're sort of selecting and then doing that. And the same thing with runtime partition pruning, which I think we added in 13. That only worked for selects, right? So if you had a case where the constant was changing in the execution stage, insert and update couldn't deal with that. We just couldn't optimize that. We couldn't trim. We'd have to go to every partition. Now, in 14, your update delete is going to use what we call executed time partition pruning, like select had been doing for a couple of years now. So it's kind of bringing insert, update, and delete up to the same quality, I think, that we had select in previous releases.